In this session, I'm trying to demonstrate some kind of use of software-oriented architecture to solve architectural problems throughout some problem statement. So let's start the session. So yeah, first let's discuss about what is the problem statement. Let me explain it. So Department of Computer Engineering consists of multiple research groups. Each group operates somewhat independently and has its own people, activity, and resources. And also, each research group may include lecturers, students, alumni, maintainers, contact persons, and they can also have list of publications. They work on different type of research projects and activities. They have collaborations with internal groups or external groups like external another department, another university. It can be collaborations. Various of facilities and resources. Each research group may contain various facilities and resources. They will produce publications through papers, articles, and can be some research posters as well. And they will maintain their own group specific website. They conduct various events, workshops, publish news, posts, and articles. So for now, most of the research groups will maintain their own websites to work on those things, cover those functionalities or requirements. But the issue is that they had to do everything by their own. Like there are a lot of most of the pages will have staff, student details, publication details, news and events, project details by their own. So there are a lot of duplications. So we need the system, a unified system to manage people associated with each group, research activities, facilities, resources and publications, and website content management. Those we need to have some better way to manage without repetitive works. So as a department, we have our own some services or resources like we have staff student details as a service, API service through this api.cepdnac website. And we have publication details, news and event details, project details. All are, we already have those as separate independent services. So we can use those services or resources to integrate with different websites associated with each research group. So how it can be done? Yeah, the traditional way is something like that. Let's say we have a website, SQL. So it will use students API, staff API, projects API, publications API, news API, events API to manage its own content. Same likewise, the vision.ce.pdn.ac.lk will use same services. Parasam also use same services, same API resources to support the functionalities. And if we have more research groups, we have a complete mess like this with different integrations. So that's where service-oriented architecture comes up. With the service-oriented architecture, we can simplify this connectivity or interactions through enterprise service bus. That is what the service-oriented architecture recommends to solve this kind of problem. So the enterprise service bus will be work as centralized service provider to communicate in between different services. In this case, the services will be students API, staff details API, projects API, publications, news. So likewise, they will be all connected into our enterprise service bus hosted in department. And each website can also, these also can be considered as different services that will represent data as a website or web pages. So those are also some kind of services. Those are consume other services. So these are the services that produce data, and those will consume those data available through the different APIs. So our enterprise service bus will do all the mapping, transformation, and configuration, and it can prepare research group specific data. For that, there are multiple ways, not only one way we can do. We can design it by ourselves. I will go through some options in the coming steps. So there are only one way. We can have multiple ways and lot of different options through the enterprise service bus. But in this demonstration, I will use this kind of implementation. So we have 6 different APIs. Those will have generic data like all the it will return all the data, and we in the enterprise service bus we will have set up some configuration with data mapping, data filtering, and transformations to expose this kind of new API service. Let's name it research group API service. So it will have for our research group, we can have slug or shortcode for each research group. And when we make some API request to this research group's API service, it will go through these APIs, do the filtering, transformation, mapping, and let us get only relevant details. So the research group websites can consume those managed APIs to get only relevant details for their requirements. So the websites don't need to handle complex mapping, transformation, filtering by themselves. They can directly use research groups API service that will be introduced through our enterprise service bus. So for the demonstration, I am using WSO2 integrator MI. That is a nice extension, open source extension. We can install through our Visual Studio Code, and with after it get installed, we can easily design our enterprise service bus through this WSO2 integrator. Or shortly, it will say MI integrator. So install guide is in here. You can find it, and yeah. So next, let's discuss how we can proceed. So I already installed this WSO2 MI integrator. So it will need some dependencies, Java, JDK version, some version of Java development kit, and WSO2 integrator MI runtime. So once it is get installed, we can see there is some additional tab available in here. So if I visit here, we get a chance to create a new project. So let me create a new project for the demonstration. Let's say I will name it as CE ESB. Yeah. Okay. Okay, so this will be the project name, and I will use the default location. There are some advanced options we can configure. So I will keep the default values, and let's create the project. So now you can see there will be some folder structure automatically generated, and this will be some kind of Java project. So for the I will initialize Git repository, and yeah, commit the initial setup so we can easily track what are the changes happening. So meanwhile, you can see the WSO2 in platform extension will get initialized. So yeah, what now we need to do is set up some kind of mapping. So I will choose one part how we can do the publications mapping to this API endpoint. So for that, we are using our API portal, department's own API portal. And here, all the resources, APIs resources are well documented. So let me choose the publication API and see its API documentation. So this will be the API documentation. We are using the Swagger JSON to define the documentation, and with Swagger we can easily convert it into this kind of test bench. We can easily go to the available API endpoints and try it by ourselves. So this is the API documentation, like the API definition. This will use some standard method to define all the API endpoints with standard pattern or schema. So it will, for each API endpoint, we will have the get method. This all API endpoint have get method and have some description, explain what it will produce, and the sample response and the schema of the response. So those are we can see as paths, and under definitions we can see some kind of JSON schema that will explain what are the types of returns of the API endpoints with some examples. You can see. So for the mapping, I am trying to use this API endpoint. It will filter all research publications under research groups. So let me try it in here. We don't need to give any parameter. It is get API. So I will execute, and we can see all the research publications filtered by research groups. Let me show it. If I expand, collapse those, I can see the research group name, and under each research group, we can have list of publications for the related to that research group. So what I'm trying to do is build up this mapping and transformation for the publications API to this endpoint. So let's go into the project, MI integrated project I created. So yeah, first we will try to add some external integrations, external services. So I need to define an endpoint. So it will be HTTP endpoint, and let me name it as yeah, this, let's use some descriptive name. and my URL template will be this one. So I will put it in here. I only need the get method, and we have some additional configuration options. We don't need any authentication. I will keep everything other configurations by default and save. And for the research groups, we also have another API endpoint or service through our portal.cepdnaclk that will give some basic information about our research groups. So let me show it to you. So research groups, we can in here we can configure and update research group information. We can have set up who should be the contact person, cover image, kind of things. So that details will be available as a separate API endpoint in here. So we will use some set up another endpoint to get access to this API as well. So I will add another API endpoint. Let's say okay, computer vision research group, computer vision. We can use any naming convention. I'm using very simple one and keep the remaining details as default and create. Now we have two endpoints, and for you can see now for each endpoint it will get created some XML file with some details. You can see this is some kind of schema the MI integrator is using to define the endpoints. Okay. So next thing I need to create an API endpoint, something like this. So there are various ways we can do it. For the simplification, I'm using yeah, let's say research groups. Yeah, maybe for the there are a lot of different ways we can do. For this, make it simple. For the demonstration, I will use new API resource for this entire part. So let me show it how we can do. I will create another artifact and use HTTP API service, and the URL will be maybe vision research group. Yeah, I'm trying to implement this for computer visions. Yeah, this one. So yeah, let me show the website as well. So this one will be the computer vision research group website. And for now, all the information, those informations are hard coded in the website. Now what we do is create an API service to make it available for this website to use that API endpoint to easily fetch the latest information. So I will use the vision as the slug. So yeah, and versioning is a good thing we can follow up. The integrator also support URL based versioning, but for the simplification, I will use this one, or we can directly use this way. By the way, I will use this one. And we can define the API from Open API definition. Open API definition is something like this one. So, but for this one, I will do configurations by manually by myself. So let's create API. So here we can see there is a now get API under this path. Okay. So I create another API resource. Let's say, yeah, publications, and it will map this one. So what I need, yeah, let's create it first. It will only get API. We don't need any external configurations. Let's create it first. So yeah, maybe now we define this API endpoint slash publications slash this one. So for the same, first I let me try this one. So if I click, we can see some GUI kind of GUI we can use to drag and drop, configure how what should be happen if someone visits this API endpoint. So what I need to do is we have this API endpoint, and inside it we have another sublist of publications related to computer vision. So I will on call this API endpoint and filter only computer vision related publications. For that, let me create and in here we have some option to call endpoint. And through that, I already have configured our publications filter by research group endpoint. I will use it, and we can add some description if we need. Let me add some small explanation. Yeah. So now we will, when we have an API call, it will call this API endpoint and fetch the data. Next, we need to map the data. So I will name it as research group. We can use any name. Let me, yeah, actually I need to create a new one. So let's create it and add. So now we have another view. We can use input schema and output schema, and we can define how data should be mapped. So let me click here. So we have several options. We can import the schema from JSON schema by schema itself, or we can import some sample JSON file, and then it will automatically identify the schema. So for the sample, I will copy all these entire payload and paste it in here and save. Yeah. Now you can see it will automatically identify the schema. So here we can see it identified the way the input will be given. So the output, it is up to us to define how we can do it. So let me try define some output schema by myself. There will be some value response, and say add some metadata. Those are not very constrained. Like I just adding something to demonstrate what we can do. Like and finally data. Data will be the list of publications, and this one maybe success, and we can say return number of research publications in here. Let's say 10. This will be some sample sample response, and I will click save. So it will generate an schema by itself. Okay. So what I need to do is map this computer vision details into this data. So I click those two, and yeah, that is very simple. One to one, this entire input array should be mapped into output array. Yeah, I click that. Yeah, simply we get a chance to map the data. So yeah, we might need to calculate the count as well. For that, let me um create a submapping. Maybe okay, add, and the input will be this one. Okay, yeah, this one. And I will use some custom function to count the number of items. So, okay. So, yeah, okay, input. Yeah, maybe we need to do something. To, yeah, let me choose the UI to draw some further things so we can do mapping easily. So I will draw it like this way. So it generated does some kind of some kind of configuration is we can do it easily. Yeah. So okay, I need to make it with like I need to write a counter. So maybe we will rename it as input, and we will return length. So this will be the publication. Yeah. So okay, I will do some manual modification to this one. Okay, we don't need this one. Yeah. So will be something like this. And I previously said our output also have a status. The wait, this what will be the output format? Yeah, response. So this will use some TypeScript function to do the mapping. So response, I maybe say hard-coded success value. So this will be the first map function. It will map the input. Input will be this. This is the identified schema. So it will only filter computer vision as the for the data, and for metadata we have a counter. Counter will count the number of publication in the computer vision. Uh, this computer vision list, and the response will be success. So that I did is in language wise. And if we come into here, we can show sheet, right? Okay, that will be simple thing. And if we see it in here, we can see the configuration we done as like this way. Each one will show clearly in here as a code. So yeah, let's move back into our data mapping. So the data mapping is fine. Okay, we need to go again in here. So we now completely map the data. So the last part we need to map, return the output as a response. So I will add the response mediator. Yeah. Additionally, yeah, now it will end. But we can have additional features like if we want to log the use of this, we can add some login option in here. Like this way, we can add some custom message or function and add. Yeah. So this one is the API endpoint for the publications. I will do the same for this one as well. We'll add some at the API endpoint we added previously. Yeah. And I will quickly add data mapping. Okay, I need to add new. And create a new mapping. And the input schema will be this one. So, and for the output, we can define our own one. Let's start with very simple one. I will use the same, but with no metadata. Okay, we can save it with later, change it with later. And yeah, so we can map the output. And there are some nice features like it can identify an automatical map. Let's try using the AI. Yeah, you can see most of the data automatically get mapped. So let me save it and see how it was written in the code level. Here you can see there are two interfaces, input and output. So here how it have mapped. So maybe I prefer to move it into the data. So what I can do it define the mapping function in here. Okay, maybe I don't need that part as at all. I will remove it and code name description. Maybe I prefer to have my own custom code. So I can modify it like this way. So every time the code will be not the code written in here, the computer vision. I'm just using the vision, and I can manually configure some custom name, description, primary contact person, maintainer, page, likewise the informations. So yeah, data mapping is now updated automatically. We can see it, and let's go back one more again into here. So the publication API is now correctly set up. So maybe I will show those here. So this will be the API definition. It will use XML to define the API endpoint. So we can see how data mappers input schema, output schema, and configurations happen. And yeah, login service. So these are the artifacts we have. And I previously mentioned we are using Open API schema for the APIs, define APIs. So this will be one of auto-generated schema, YAML-based schema, which is very similar to this JSON-based schema. Okay. So yeah, here we can see the transformers and everything. So let me comment that. Yeah, so those are all ready. So let's move into the micro integrator again. And yeah, we can see in here also endpoints, data mappers, resources, API definitions, YAML-based API definitions, metadata. So yeah, and the APIs we define by ourselves, right? So let's go into home page and let's try to run it. So this project is actually some kind of Java project, and it will use Maven for the package management, and code generation is completely automated through this extension. So we can see it will build the project, and then once the build is completed, we can, yeah, you can see now it will do build the data mapping. Yeah, everything fine. Now it will turn up the server. Like so we have several options, like we can use this project files and build some Java application, or they will provide some option for us to create a build Docker image. So it will be complete Docker container. So we can directly configure to deploy it directly into Kubernetes platform. Yeah, there are many other different options. So meanwhile, I can see now the service. Yeah, okay, there are some small issues. Okay, let me see. Okay, let's try. Yeah, so that will be the issue. We need to configure it again. What is the issue? API context must begin with slash. Correct. Yeah, this one need to have slash at the front. Okay, I will rebuild it. Yeah, now we can see this one. One API endpoint or API service is now available, and that under that we have two API endpoints. We can use this Swagger view included in the extension itself. It is the same file available in here. The Swagger is some kind of common schema that will define the API services through the open API definition. Like the open API is the way define the schema, and Saga is a tool that will build some kind of this kind of UI based on the open API schema. This one will be the Saga output, Saga UI, which is also the same this one. Okay, so now API endpoints are available. So we can try it in here or in the browser itself. Yeah, I think I missed some part. After the data mapping, we need to return the response. So I will add the response and rebuild the server. So we need to make sure every time the output is sent back to the requester. Otherwise, it will get timeout like this. So yeah, I will rebuild the application again. And now service available again. I will call this get API. Yeah, now I can see the details. Let me show it in the browser itself also. So we have come up with new API research groups v1/vision. So now we can see the transformed data from this API to this one. Okay, let me show it in here like this way. Uh, where is the API? Oh, yeah, this one is the actually input and this one is the output. Okay, so yeah, you can see why define custom mapping, it will work. And same way we can, how we can close this? Yeah. And then we have done another API publications, right? So let's see. Yeah, we can see there are publications. We can see there are 6 publications, and we can in the metadata we can see it is correctly counted as the count and the response. So these are the directly mapped from here. Computer vision, there are 6 publications. Those are currently mapped into research groups, V1 Vision Publications API. So that's how we can define API endpoints through enterprise service bus. So yeah, that's the way we can do. We can do the other API endpoints as well like this. We may need to let me show. Here we can add new resource, like let's say people, and create no slash here. And we can use some different services like for the people, list of people, maybe we can have connected into some database lookup. We can define the database connection details and SQL query to map the list of people, maybe students and staff in here. So that's how we can do the integrations. We can easily use this GUI and set up our own API resources. And if I need some for uh, similar for the, let's say, SQL, I can make a duplicate of this one and configure it for the computer vision as well. From the files, I think copying the files will be easiest option, like this way. And we may need to configure this things as well. So maybe I will create it using the GUI and copy the schema. So those are the possible things we can do. Yeah, this is now we come into the end of the demonstration. And let's go to the slides again. So yeah, that is how we can define the enterprise service bus to map details from here to here. But now you are wondering that like you can say with some Python script, I can do all these things very simply, not complicated like this. I can write some Python script and generate all the details easily compared to this one, right? So some small application, Python fast API application, we can do the same thing without enterprise service bus easily and deploy it as a regular service. Yeah, that is correct. So for the small scale applications, our department, actually it is very small scale. So it will be fine. Yeah, we can do it that way. We can write some small web service through Python, Java, PHP, any language, and do it by ourselves. But let's say if we go into higher scale application, like maybe in large organization level, it will be always convenient to do the configurations through some uh, application level interface uh, rather than writing codes because we they can reuse the resources. Let's say for department this will be fine, right? But let's assume we are designing some enterprise service bus for faculty of engineering, or let's say more into like University of Peradeniya. So it will be very complicated. Like for the research groups in the University of Peradeniya, we might have large number of research groups, and they will have different ways. Like for our department, we had students API details, staff API, all things in as APIs. But if we go to set up some system like in university level, maybe we don't have those all API services. Might be we had to provide the staff details as CSV file or from Google Sheet. That can be happen. Like we can have a Google Sheet and export it as API endpoint. Maybe yeah, that we were to share. Like let's say maybe okay, yeah. Somehow this will not works. Like we can create a Google Sheet and export in the Google Sheet. In here, share, we have an option to share it as a CSV file. So we don't need to have a manage and a separate backend. The Google Sheet, the CSV file, we can easily convert a CSV file from here to JSON. Yeah. So CSV to JSON we can do with some application written. So yeah, that way we can easily bind this staff informations from Google Sheet to API endpoint through our enterprise service bus. So that is the main purpose. Like enterprise service bus will help us to map, filter, and transform data from various formats to various other formats and do configurations easily and manage very complicated situations with very simple way. So that is the main purpose of enterprise service bus. And yeah, that's all I wanted to share with you guys. And yeah, thank you all. I hope you get something. And if you have any doubt, please something need further clarifications, feel free to contact me. I will publish the GitHub repository and share with you the link so you can also see and try to implement the remaining API endpoints by yourself also. Okay, thank you all.